Hello there and welcome to Ancient Theories channel. In my last video I tested the Lapis Lazuli's magnetic properties and encountered a quite enigma. You see, the Lapis Lazuli rocks were used by ancient to create aquamarine pigment, and at one point that pigment was more expensive than gold. Yes, to buy 1 ounce of aquamarine pigment you had to pay more than 1 ounce of gold. That is insane due to the fact that the Lapis Lazuli rock isn't that rare at all. So, how did they process the Lapis Lazuli rocks into pigment? By the way, this process is called pastello extraction. They ground the Lapis Lazuli to powder and then kneaded it with a paste of resin, beeswax and oil, like an artificial geode. After a week or two, the thingy with Lapis Lazuli powder was rinsed out under water. The ultramarine was released, while the impurities remained behind in the paste. After filtering and drying, you have your precious pigment. But wait, there is more. If you would like to do the exact thing I just stated, then you will get poor quality pigment, not worth even the same as gold. To get the good quality required to start the process by heating Lapis Lazuli to reddish color, then grinding. And what's a big deal? Well, what is the reddish Lapis Lazuli? One source states that there once was red-blue Lapis Lazuli, which was lazurite mixed with red agate, but it wasn't used to create pigment. It was treated as a gemstone, which is fair after all. Red agate is truly beautiful on its own. Then what on earth is reddish Lapis Lazuli? I tried to burn it with an isobutane lighter, but there was no result. Then I used a flame torch with butane, but instead of reddish, I got blackish, which was due to impurities in my piece of Lapis Lazuli or something else. I stopped right there. But this time I changed the flame torch butane tank and decided to clear my rock with sandpaper. If you are interested, the sandpaper didn't reveal anything at all, just clear the surface of any impurities. Disclaimer time. Do not try this at home. Heating Lapis Lazuli rocks may release toxic gas, sulfur dioxide, which can be a hazard to your health. I did have precautions, and all of this experiment was carried out outdoors without any humans in the perimeter, except for me. When dealing with rocks heated with butane flame, one should expect to get extreme temperatures of the heated rock. Do not place it on any flammable surface. Mine Lapis Lazuli rock was set on a few pieces of calcite, which was stabilized by clay, and all of that was on a ceramic tile, which can withstand high temperatures. Let's see the burning process, shall we? Nothing crazy for now. It was quite hard to do it properly with a smartphone in my hand, so I continued for the next 2 to 3 minutes without the camera. Here is a later clip. After 2 or 3 minutes later, I was done. I had an infrared thermometer on me, so you could see the temperature of the rock. Keep in mind that it can only tell temperatures up to 400 degrees Celsius. To be honest, it wasn't getting cold as fast as I thought it would, but the temperature of the stone at some point could be up to 900 degrees Celsius because butane flame easily goes up to 1,300 degrees in flame torches, which can be the reason why the thermometer showed 350 to 400 degrees Celsius for such a long time. Time for inspection. At first I was certain that I achieved nothing. When I thought that my stone is cold enough, I took my smartphone loupé, and here is the video of that inspection. Okay, there is a reddish spot, but wait, what is that? A glowing pyrite. No, it's more like silver or mercury. What on earth is it? Some kind of mix of sulfur oxidate and pyrite or what? Well, it appears that the stone wasn't cold enough and the paint on my lupe decided to smear all over the place. Plastic doesn't like high temperatures, and who would ever examine rocks hotter than 200 degrees Celsius with a smartphone loupe? It appears that, well, me. And that glowing pyrite was just a painted pyrite with some unknown cheap Chinese polymer or something. At this point, I was not only disappointed but also angry. I felt that the sources lied to us about the reddish color. My knowledge told me that after all, I should get not reddish but white powder on my rock due to the fact that sulfur oxidate, not dioxide, can settle as white powder. I was going to wrap up this experiment and call it a day. However, you see, I didn't want my piece of Lapis Lazuli to stay in such a state with random paint marks on it, and after all I had on my table sandpaper, I decided to use it to clear that paint from my rock. And it was unexpected. I already used sandpaper once before this heating and it revealed nothing. Who knows that this time will be different? Here, look for yourself. Do you see it? And here, I have the reddish Lapis Lazuli piece just like in the source. Where is that lupe now? Let's examine it closer. Lazurite is unchanged, but pyrite is no longer goldish. It appears to me that pyrite veins oxidated due to the heating and created sulfur dioxide, which was that colorless gas, and the reddish thing, which is common rust. Pyrite is in fact a mineral which contains sulfur and iron, and due to oxidation those two elements decided to form oxidates, and rust is a term for iron oxides, which is a group of chemical compounds of iron and oxygen. But the common rust is brown, not reddish. Well, in my experiment the atmospheric conditions were, let's say, more humid this time. It was raining a little at the time, but the experiment was carried out under a roof. Nevertheless, the air was humid, it was raining for a few hours already, and the rain was becoming weaker, but still. When you oxidize iron in humid or simply wet conditions, you get iron oxide hydroxide or ferric oxyhydroxide, which is the orange or dark orange rust. And I got just the thing here. I do not remember any source stating that one should put Lapis Lazuli rocks in the water before heating, but it states that one should clean Lapis Lazuli rocks from impurities before heating and grinding. That was the reason for my sandpaper work at the beginning. There was nothing about water before the 2-week period after the heating. Who could have guessed that? 2 things before the end of this video. The pyrite veins in certain conditions can transform into pyrrhotite, which inherited its name from the Greek word pyros, which is literally flame-colored, but it is not orange or red, more like brassy. And that mineral can be magnetic, but only if it's not rich in iron, which is counterintuitive. But if it is rich in iron, then we call it troilite, and that thing has no magnetic properties at all. And those 2 minerals are basically the same, but pyrrhotite has definitely more sulfur than iron in its composition. And in pyrite, we have exactly a 2-to-1 ratio of sulfur to iron atoms. So, for magnetic purposes 1-to-1 is bad and 2-to-1 is bad, got it. Then how to get the sweet spot and create pyrrhotite? I don't know, yet. In nature, it appears that pyrrhotite can form near black smoke or hydrothermal vents, and I don't have one of those in my home. The second and last thing is that we, the current living humankind civilization, used to study rust. In fact, some people created iron oxide hydroxide gel which has strong magnetic properties when the substance on its own is not magnetic. To be specific, quote, the Sol gel technique is defined as a colloid, that is, a dispersion of solid particles with diameters ranging from 1 to 100 nanometers in a liquid, in which, after some process, the particles become interconnected, forming a rigid network with pores of submicrometer dimensions or polymeric chains. Brinker and Scherer, 1990. But I don't believe that it was the Neo-Babylonians or Greeks could use that technique. But the pyrrhotite? Who knows? Till we meet again.